Good morning, sir. My name is P. Lakshman of Electrical and Electronics branch. My roll number is 20955A0212. Subject is Power Systems Analysis. Today my topic is about per unit system representation. First of all, we have to know about what is per unit system. For the analysis of electrical machines or electrical machine systems, different values are required. Thus, per unit system provide the value for voltage and current and power and impedance and admittance. The per unit system also make the calculation easy as all the values are taken in the same unit. And the per unit system is mainly used in the circuit where the variations in voltage occurs. And definition of per unit: the per unit value of any quantity is defined as the ratio of actual value in any unit to the base value or reference value in the same unit. Any quantity is converted into per unit quantity by dividing the normal numerical numeral value by choosing the base value of the same dimension, and per unit value is dimensionless unit, and per unit value is equals to actual value in any unit by base or reference value in the same unit, and the base value can be selected arbitrarily. It is usually to assume the base value is given below. Base voltage is equal to rated voltage of the machine. Base current is equal to rated current of the machine. Base impedance is equals to base value voltage by base current, and base power is equals to base voltage into base current. Firstly, the value of base power and the base voltage are selected, and the choice automatically fixes the other base values as the per unit kV voltage kilowatts is equals to actual kV by base kV is equals to kV actual by kV base, and also base current is equals to IB is equals to base kVA by base kV is equals to kVA base by kV base, and per unit current is equals to I actual value of current by base current. This is the second equation. The putting the values of base current of the first and second equation, we get per unit current is equals to actual value of current is equals by kVA base by kV base formed, and per unit current is equals to actual value of current into kV B by kV base is it's into actual value of kV into VV and kVAB, and base impedance ZB is equals to base kV into 1000 by base current. This is the third equation. And now putting the per unit equation 7, putting the value of base impedance from the equation 4 in the equation 5, we get the value of impedance per unit, and per unit impedance is equals to actual impedance by base impedance. Per unit impedance is equals to actual impedance into kVA base by kV base square into 1000. And coming to advantage of per unit system, there are two advantages of using per unit system. The parameters of rotating electrical machines and the transformer lie roughly in the same range of the numerical values in irrepresentative irrespective of their rating and expression in a per unit system of ratings, and it relieves the analyst, and it gives the need to reference circuit qualities to one or more other side of the transformer, making the easy calculations. And the taking the example of transformer having the resistance in per unit and per unit or resistance per unit ohms, and the reactance is per unit in ohms, and the reactance per unit in ohm which referred by the primary, then the per unit values is equals will be resistance per equivalent per unit is equals to equivalent resistance by base impedance is equals to equivalent resistance by vi primary voltage by primary current. And similarly per unit reactance is equals to equivalent reactance into primary current by primary voltage, where the equivalent resistance in and equivalent reactance and or resistance and reactance is referred to primary and per unit means in the per unit system the resistance and leakage reactance refers to the primary in per unit are the same as referred to the secondary per unit system, because the per unit equivalent resistance per unit is equals to resistance equivalent into R equivalent to I1 by V1, where R equivalent R equivalent by K square into K into I1 by V1 by K is equals to RES I2 by V2 is equals to RES per unit. And reactance per unit, reactance equivalent per unit is equals to X equivalent into I1 V1 and X equivalent K square into I1 into K into I1 V1 by K. X is V2 and XES per unit, and the where RES is into reactance equivalent and resistance equivalent refers to the second. Therefore, the from above equation, it is clear that we need the ideal transformer is eliminated. This is so because of per unit impedance is the same for the equivalent circuit for the transformer, where the computed from the primary or secondary as well as the voltage based on the two sides are selected in the ratio transformers. Thank you.